Let me introduce the gentleman again. Yannis Skulikaris is a director responsible for 30 patent examiners in the computer field in the European Patent Office. He holds degrees in physics and computer science. He has been active for more than 25 years in patent protection in the computer field in positions of increasing responsibility. He has been involved in training examiners in devising and implementing the EPO operational quality control system and in defining guidelines for the examination of computer-implemented inventions in the EPO, the European Patent Office. He is a guest lecturer for European patent law, in particular for patenting of computer-implemented inventions at the Law School of the Maastricht University. And his partner in this presentation is Koen. Koen Lievens, do I pronounce that well? No, I don't. You teach me then. Okay, as soon as you got your mic. He is DG1 Director at the EPO, the European Patent Office. His directorate comprises 39 telecom engineers in charge of patentability searches and patent granting in the field of wireless and data switching networks. Additionally, Koen is head of the C2 Guidelines Working Group, a cross-joint cluster task force inside the EPO. I abbreviate now. The workshop will explain the current legal framework that applies when dealing with the technical area of computer-implemented inventions, focusing on software inventions, and will illustrate the patenting practice of the European Patent Office with easily understandable examples in an interactive presentation followed by a Q&A session. My admirations for guys like those is that I'm struggling as a user with a software program. I already admire those who create and develop software programs. But those who then examine them, having a view of the whole market and distinguishing this is nice and this is new, this is a cool creation and this is a true invention, that is their science. That is what their teams are working on every day. So if there's anyone in the world you can ask a question relevant to your business creation, those are the guys. Please welcome Mr. Lievens and Mr. Skulikaris.
Yeah. Thank you. Welcome everybody. Thank you very much for being here. When we were starting this kind of presentation, we were devising this kind of presentation, we were asking ourselves what would be the best examples to present so that you grasp the idea of whether software is patentable or not. And so we were struggling with some ideas, but the best idea came from the audience a few minutes ago. So could you possibly patent excuses? Of course, excuses are not necessarily implemented in software. They might be sometimes, but nevertheless, okay. So to come back to the title of our presentation, is software patentable in Europe? This is a much debated issue, as you probably know. It makes every now and then the headlines in the press, in the internet. It is also an issue which is quite misunderstood, because sometimes people on this side of the Atlantic and on the other side of the Atlantic speak about software inventions, but they do have different perception of what software inventions really are. So, and I hope that Koen and myself, we will be able to convey to you this a perception of what we mean in Europe when we talk about software inventions. So there is a need for information concerning this subject. And to get you going, to get you thinking, I would like to confront you with 3 cases that are quite typical and helpful in order to understand what we will be talking about. So just imagine that you are on the highway driving your car, the level of fuel goes down, and you have somehow to find a fuel station. Then there is a nice system which is coupled to GPS and coupled to the fuel indicator in the car. And early enough, when the level of fuel has reached some critical point, the system gives you an indication as to where is the nearest fuel station. And it gives you also the route to the nearest fuel station. So you might ask yourself, of course, the system has a very essential component in software, obviously. So you might ask yourself, is that kind of system patentable? Or imagine that you are in China, you don't speak Chinese, you are struggling to find somebody who speaks English next to you, and then on your smartphone you have an application that indicates to you that within 20 meters around you there are two persons speaking English, which might be very helpful, of course. Or think of a long transatlantic flight where you sit in the plane and you wish that the person sitting next to you would have similar interests like you, for instance, ICT technology, politics, or fashion. And then, of course, the long journey could be much more pleasurable. So, at the end of this interactive workshop, what Koen and myself, what our ambition is, we aspire to make you, to enable you to understand a little better than your present understanding as to whether these kinds of applications, methods, could be patentable. And having said that, I would like to hand over to Koen to deal a little with the contents of the workshop and the legal provisions.
So thank you, Yannis. So I think you have the idea, and so the motivation for our talk is clear. These were very nice examples, and at the end of our talk, we will come back to them. And in an interactive session, you can think together with us as to what you believe would be patentable indeed. So with this, we more or less have already set the scene for our talk. And now what you see on the slide is the program of our presentation. First of all, as a kind of a necessary evil, I will talk to you about our legal framework, that is the articles of law which define the criteria for patentability. Of course, within this framework of law, we have a standing practice which we have developed. It is a very stable, well-established practice, and we believe it is a benchmark worldwide among all patent offices. Of course, in this practice, today we will talk especially about software patents, so we will zoom in obviously on this theme, and we will also share with you the challenges we face in this topic. And then, as already said, we will finish our session in an interactive way where together with you, we will develop some ideas about examples. Okay, but now then, straight to the core of our legal framework. I'm afraid I have to check. Yes, this is the Article 52. Article 52 is really one of the core articles of our European Patent Convention. If you just read already the first paragraph, it's actually one line, but it brings together the main criteria for patentability. So what you see there is patents shall be granted for inventions in all fields of technology. So the technology aspect is very important because indeed patents are about technology, not about some abstract idea, not about an excuse. It has to be technical. And also in the same first paragraph, you see the main requirements of novelty, inventive step, industrial applicability. So these criteria, obviously, we will come back to them in the rest of our presentation. Now, if I may draw your attention to paragraphs 2 and 3 of the core Article 52, This, in fact, was defined by the founding fathers of the European Patent Convention, who had in mind some kind of a limitation to what can be monopolized, a guarantee of freedom, in fact. And if we go through the list, you will see that the main theme is technicality. So again, patents are granted for technical inventions. If you look at topic A, discoveries, scientific theories, mathematical methods, well, these are clearly property of mankind. They should be free. If we look at aesthetic creations, well, they are not technical, and there's other forms of intellectual property rights to protect them. So we are talking about copyrights, design models, etc. Then, of course, in topic C, the schemes, rules, and method for performing mental acts and doing business. Also there, this lacks technical character and shall not be patented. A very interesting one, also mentioned already in this list, indeed, are programs for computers. Now, this is a really special one, and so my colleague Yannis will zoom in on this term in a moment, because a program for computer is, well, like a program listed, it's like programmed by a programmer. It can be considered his own individual creation of putting a text together, and that's why it's also protected by copyright. However, a computer program has this very interesting characteristic. When you run it on a computer, it somehow creates functionality. It does something which has not only to do with the computer or the software. It can then bring what we call a further technical effect. And this is why we believe that software as an implementation of a technical invention merits indeed the protection of a patent. Now, whilst paragraph 2 lists the subject matters which are of an abstract character, not technical, which could sometimes even be qualified as a mental act, the application of the paragraph is very much limited by the Article 3, which we in our jargon refer to as the as such requirement. So these subject matters are only excluded in as far as the whole subject matter for which protection is sought relates to this as such. So that means if there is no technical elements present whatsoever, if the whole of the claimed protection is about a business method, if the whole of the claimed subject matter is about an aesthetic creation, clearly it is ruled out. So this as such requirement limits very much the application of this Article 2, and this is why, in the end, a program as running on a computer and implementing this technical invention will, at the end of the day, if it's novel, of course, and inventive, be patentable. Okay, then I already said Yannis will zoom in a bit on this aspect of programs for computers and will give you some more information.
Thanks very much, Koen. Koen already indicated a basic property of software. You could read a program like a literary work, or you could focus on the functionality created by the program, and that is a very intriguing property of software. It runs on a computer, it develops functionality. However, software has also a second quite interesting and quite intriguing property. And if we go a little to the previous slide, I would like you to focus a little on the list of exclusions, and I would like to guide you through this list and exhibit this special property of software. Imagine that you can use software, for instance, to program a scheme, rule, or method for performing mental acts. For instance, we know that neural networks, which are programmed in software, can somehow replicate, to a certain extent, the way the human brain functions. Or you can use software for an aesthetic creation. So you can use software to display nice fractals on your computer screen, which has an aesthetic effect. Or you could use software to program playing games. We see that every day on our screens. And of course, you can use software for doing business, to program a method of doing business. So the very intriguing and unique property of software is that you can use to implement a big part of the exclusions of patentable subject matter as set out in the law. And that means if we continue our thinking, we come to a very interesting finding. If we allow the patentability of any computer program, then we bypass the exclusion of, for instance, business methods, or of methods of playing games, and so on. So one extreme would not function. We should not allow the patentability of any computer program. But on the other hand, if we totally exclude any implementation that is done on software, then we definitely exclude some subject matter which is quite technical. And we will see some examples in a few minutes. So my contention, my statement is that the two extremes do not function. We cannot allow anything that is programmed by a computer. So we cannot allow everything that is programmed by a computer. And we cannot exclude everything that is programmed by a computer. So our viable way should be somewhere in the middle. But in the middle, of course, is the gray area. And that is exactly what is the interesting issue and the challenge. So we have to have a kind of criterion, a kind of approach to judge which computer-implemented, software-implemented inventions we should allow. And the idea that helps us, the notion that helps us in this approach is the so-called technical character. And this will be one of our focal points in the next of our workshop. So, and with this, I would like to give over to Koen.
Okay, so then indeed the next slide. So as Yannis said, technicality a main requirement, but not the only one. We have very high standards in assessing patentability. And if you look at the first phrase on this slide, already again we summarize what was written in the Article 52. So the big lines are novelty, inventive step, industrial applicability, and this all in combination with technical character. So now if we look at these requirements one by one, I can say the following. So novelty is a pretty clear criterion. Patents should be granted only for inventions which do not exist already. So for this, we are doing our what we call patentability search. So our examiners study the applications and they will retrieve what is already there, what is already published. We have huge databases, access to all the standards, and this will allow us to assess whether indeed what we have on the table, what we are looking at, is novel or not. The second very important criterion is inventive step. So if there is indeed a difference, what we call a distinguishing feature, difference between the claimed invention and the closest art, so the state of the art, then we have to assess whether this difference is just a normal, to be expected progress of technology, or whether there is something special, something unexpected, so whether it has any unexpected effects, and then hence would merit indeed the protection of a patent. And then back to the technical character. So what you have here on the slide is in fact repeating the interaction between Article 52, 2 and 3. This is what we refer to in our jargon as the first hurdle. So you look at a claimed subject matter and it has to have technical character. It should not be just abstract. But the point I want to make here is that this technicality is also important in our other assessments, so in the assessment of inventive steps, so we will come to that also later in our talk. The contribution which the claimed invention defines over the prior art, so the difference with respect to the state of the art, has to have technical character. It is not enough to have a difference, because the difference could be just a business method. The difference could be just a presentation of information which is more aesthetical. So the difference which will be assessed in the inventiveness assessment has to have a clear technical character. Now, technical is a concept which is not as such defined in our law. We have a reference to technicality in the Article 52. We have some references to technical character in our implementing regulations. And of course, we get guidance on technicality from decisions of our second instance, so the boards of appeal. Our boards of appeal are the instance who can review decisions that we in the patent granting process take. And we have, of course, in our practice, some big criteria to help our examiners to assess technicality, some main questions that should be answered. So are these features defined in a technical context? Are they helping a user in performing a technical task? Is there any credible technical effect? So we do have a series of criteria which help our examiners to make judgments on technicality. And now then, back to Yannis.
Koen already indicated that it is not very helpful to go and try to create a definition of what is technical and what is not. There have been some attempts in the past to create a definition. However, since technical effect is not a mathematical issue, a mathematical notion, these definitions have not succeeded. So our conviction is that a common perception about what is technical and what is not is rather created with the help of positive and negative examples. That will help understand and have a perception of what we mean when we say technical or non-technical. And if we go to the next slide, we have some concrete examples there to give you a first flavor of what we mean. For instance, as a technical subject matter, you might understand the software used to control the ABS system in a vehicle, the system that helps the vehicle brake and steer at the same time in an efficient way. Or you might think of a system that helps an airplane while the airplane is flying to avoid terrain. You can imagine that this is a system that consists of a database of terrain and a GPS component that gives the exact position of the plane in space, and software control which gives an early warning to the pilot that if the plane continues on the same heading, then in the next 10 minutes the plane will collide with the mountain. Such systems are typical examples of what we mean when we say a technical computer-implemented system. On the other hand, if you try to approach the negative examples, you might think, for instance, of a sales promotion system which is based on a pyramid principle. You probably know these systems that operate on this pyramid principle. Or you might think of a program, obviously that would be a computer program, that minimizes the amount of tax that you owe to the tax office, which is again an application, an implementation, software created, of course, but the effect of which is purely financial, is a pure financial issue. Or you might think of a program that takes into account your investment portfolio and maximizes the return. This is also a pure financial system, and obviously you can implement it totally in software, but such a system, being purely financial, would not be protected with a patent. So these positive and negative examples are a first attempt to approach the idea of a technical system as contrasted to a non-technical system. And I think that it is interesting for you to know exactly how our examiners are dealing with this issue, and then Koen will explain that.
So yes, we are approaching the last slides of our presentation, but now here we really talk business. What exactly is an examiner doing when a file, an application, arrives on his or her desk? So what our examiner look at is what is the claim. The claim is defining the protection which is sought, so the invention is put in words, and a scope is defined for which then a monopoly is requested. Now our examiner will basically go through two tests. We call them the first and the second hurdle. The first hurdle is to look at the subject matter of this claimed invention as a whole and to see whether as a whole there is any technical character. Because if this is not the case, then this is already excluded. This first hurdle is, as you can imagine, quite easy to pass. So this is actually, we could say, rather academic. From the moment in this subject matter we have one technical element present, just a computer, a network, a smartphone, even the words, it's a computer implemented invention, is enough to say, well, maybe the most features relate to a business method, but it is computer implemented, so it is technical. So this is the first hurdle, actually quite easy to pass. Now the core of our work then is then in the second test, the second hurdle, where the examiner will do his patentability search. He will establish what is already existing worldwide by using our powerful tools and databases. And then his conclusion could be, okay, this claimed invention is not novel. So that's then end of story, not patentable. However, if there are any differences with what was established as the closest prior art, so the state of the art, then the examiner will continue his work and try to establish whether this difference merits the patent of a patent in the sense that it will be inventive. Now, for assessing inventive step, we have a very well-established argumentation scheme, which we refer to as the problem and solution approach. Now, a very important message in the context of this software patents, computer implemented inventions, is that also in applying this test, this argumentation scheme for establishing for deciding whether the invention has an inventive step, also there it's quite important to distinguish between these features which do have a technical character and the features which are not having technical character, because such features cannot bring an inventive step. They are somehow disregarded. So technicality is indeed key in the assessments made by the examiner. Now in the next slide, I think, yes, our secretary, she moved some contents to 2 slides. So as I say, so the test 1 is the technicality of the subject matter as a whole. And the test 2 I was talking about is the novelty. in view of the established prior art, and then the inventive step assessment with the use of the argumentation scheme, which is the problem and solution approach. And also there, as I said, technicality is really a key consideration. Good. So then now, these are the mechanics of our problem and solution approach. So I will be, well, I think it's important to have an idea. Nevertheless, I will try to be brief so that we can also discuss with you our examples. As I said, what is the closest prior art? So a patentability search focusing on the technical features. Having established the closest art, our examiner will identify the differences. And then in these differences, of course, it could be that there is no differences, so then it's not novel. It could be that the differences are purely abstract, purely business, then this cannot bring an inventive step. It could be then the third case, that indeed the difference is all technical features, and then we go to step 3. What is the technical effect of these differences? So what is the technical problem solved by the differences? And then would this be something obvious for the skilled person, the man, the normal practitioner in the field? So would we consider this as a normal progress of technology, or do we see any unexpected effects indeed? The fourth case, and this is a case which we often see in the fields of software patenting, in the fields of computer-implemented inventions. The fourth case would be where the difference with the established prior art is a mix of technical and non-technical. And this is then, first of all, the assessment and deciding which features are technical and non-technical is really crucial, because the non-technical features are somehow disregarded. They can be put in the formulation of the objective technical problem. So they are kind of a requirement specification for the programmer. If you ask a programmer to implement this business mechanism, well, he will write a program, and this, of course, cannot be considered as inventive. So it's a bit brief, but this is core in the assessments made by our examiners. I'm also very happy to inform you that just last year, November, we made a big update in our guidelines for examination. So this is, of course, a publicly available document which can be used as guidance for our examiners, but also for the patent attorneys and our applicants. So it is in the part G about patentability, where we have it written, in fact, so I am heading the CII, this is Computer Implemented Inventions Work Group. We are continuously working on improving the guidance, so not changing the practice, but more clearly defining what exactly we are doing, and this mechanics of the problem and solution approach in the context of the mixed type inventions, so mixture of technical and non-technical features, have been elaborated very extensively recently in our latest release of the guidelines for patent examination. Okay, so then before I hand over to my dear colleague Yannis for our more interactive part, so that's the examples, I just want to say, so the way you pronounce my name indeed is Koen. Yeah. Well, it's not exactly an international name, it's a Flemish name. So, you know, in the Netherlands and also in Belgium, the northern part, we speak Dutch, and Koen is a typical Flemish name, and quite hard indeed for an international audience as we are facing today.
Thank you very much, Koen. Easy to pronounce once you know it.
Once you know it.
Once you know it, it's easy to pronounce. Also very popular, worldwide popular last name.
Yeah. But
all kind of variations.
But then, because in your introduction you mentioned also so C2, but it's in fact CII.
CII, okay.
And this is an acronym which is really very important, Computer Implemented Inventions, because what we see today in the context of what we call Industry 4.0, so the new industrial revolution, is all driven by internet, by software. We will see software implemented features in all fields of technology. So this is really a crucial acronym. I wanted to just make sure we all understand the same. Now,
thank you very much.
Over to the example. So I hope we will have now an exciting interaction session. So please interact as much as possible.
We will not deal with the example suggested by the audience. So let's say computer implemented excuses. Koen and myself, we have chosen two examples, but I suggest that we focus on this example and then we do it
Okay.
interactively with you.
So we would first go to our second example. So Yannis, would you introduce it?
I would like to...
May I interrupt you? Just a little break.
Yep.
I would like to spice up our session with a toy.
Okay.
That allows you to go on a website, Lucas. And if you take your phone, you don't need to download an app. You just take your smartphone, please now. Let us try this, please now. Go to a browser and go into voxr.org/expert. There you have a field you can punch in a sentence or a keyword that is important to you. And after that, we will see a cloud of words. And those words appearing in your sentences that come up often will be large. So we'll get an impression of the subject matter that interests many of you. Just open your browser and go on voxr.org/expert. Now they are playing and you continue.
Thank you very much. I wonder whether we can get again our example on the screen, because then I would like you to...
Seine Seite wieder, genau.
Okay, very good.
Excellent. Yeah, exactly. Please have a look for 10-30 seconds to this example. The rest of the workshop is supposed to be very interactive, so we are open, and in fact we encourage and we welcome your feedback. Have a look at the example, and the question, after you understand what it is, well, it is relatively easy to understand. It's the resolution for the overbooking situation in an airline ticket system. After you have thought a little about this, we would like to work with that together with you and come to a kind of impression whether such a system could be possibly, which is obviously software implemented, could be possibly patented. Interesting, isn't it? So there is a main idea, there's a basic idea into this system. You go to the counter and you are disappointed because you are told that you cannot fly because of overbooking. And then you say, okay, but there must be a way to let me fly because I am the most consistent customer of the airline. I have never had a no-show case. I have always been there to fly when I have booked, in contrast to other customers of the airline who, having booked a place, did not show up to fly. So I should have a better, let's say, chance to fly with an excellent no-show record, meaning a zero no-show record, as compared to customers of the airline who have been no-showing before and maybe frequently.
Yeah.
So there must be a way to reach a resolution of this problem in favor of the consistent customers. And this is exactly what this tries to do.
So what would you think, dear audience?
I suggest a brief survey where you just say, yes, it is patentable, it can be a patent, or you say, no, it's a nice creation. You only have to lift your arm once, but you have to lift it once. Either you say, yes, it's great and it's worth a patent, now, or you say, yes, it's a nice creation, I love it, and I would use it, but it's not worth a patent. Okay, thank you very much. Again, just in case someone before felt that arm was too tired, who would say, yes, it's worth a patent? Again, no one. So, you got a comment.
It's working?
Lucas.
Yes. My name is Hani. So in this regard, I would say no. But if you add some more things, I would say yes. Some more things like we need to know if this guy is in his home country or not. So if the two guys have the same perfect zero no show, then I will select the one who is not in his home country. And if they are both not in their home country, I will select the older one. And if they are on the same age, I would select the guy who frequent more or who flies more frequent. So I will make a much more complex
Yeah.
criteria because I think if you have like 3 different seats available and you have like 10 or 15 people, how to organize them. So if it's like that, I would say no. If you are going much more in details and analytics, I would say yes.
Yeah.
Thank you.
That is a wonderful comment, but then that creates a question on my part. I understand that in increasing the criteria, you see some more contribution, but would you see a technical contribution in increasing the criteria? Because the basic thing we are looking for is whether this system solves a technical problem or it solves a purely commercial problem or an administrative or a financial problem.
This is very hard for me.
This is hard for you.
This is hard for me. I mean, so because I'm a techie guy and also work with the business a lot, so I don't know.
Yeah.
Let's see more comments, more questions or comments. Here you go.
Yeah, the question is, how do you know if software uses this algorithm or not? Like, how to claim that someone is infringing this patent if there is such thing? Yeah.
Yeah. Well, first of all, I think it's a valuable comment in that obviously this is a business rationale. It's a business idea, a way of organizing the overbooking in an airplane. And I think the comment of the Mr. there is actually, if we refine the business rationale, will it then become patentable? Well, personally, I believe no, because even with a refined set of rules in the framework of a business concept, it would still be considered outside of a technology area. Now then, coming to your question, of course, a business scheme or a game can be put into implementation with a software. So if you would then modify this claim, because obviously this is an example which would not even pass the first hurdle, because there's no single technical effect present. However, if you would say a computer implemented method, so a program software running on a computer, then the first test is passed. So it's that easy. That's why I refer to it as rather academic. But then in our assessments, our examiner will have to say, okay, but now, does it bring any inventive step? Does it merit indeed to be protected? And then he will distinguish the technical from the non-technical features. In this case, this would be a really easy exercise, because the only technical feature would be, this is then implemented on a computer as a program. That is clearly technical, so that we put in the side of the technical features. On the other side, we have all the maybe very sophisticated aspects of the business logic. And then our examiner will say, well, the only difference or the only technical aspects are really very commonly known, just a general purpose computer, and the business plan as such will be given to a programmer, and any programmer can do this. No special skills are required, and that's why we would say no, this as such cannot be patented.
Any more comments or questions? Yeah.
Yeah, I was asking more general question. How do you know what's the, like it's software, you cannot, if you are third party, you cannot know precisely how it works. So how do you extract the idea, let's say, whatever software is patented, how do you now that it works in this exact algorithm which was claimed to be patented, and yeah, you get me?
Yes, indeed. So, of course, in the context of today, where many applications are implemented in the clouds, its infringement is clearly a concern of our applicants. And they are the holder of this monopoly title, and their question is indeed how to enforce it, because it could be that one step of the method, even at one point in time, is implemented in UK. One step could be implemented in France. So you also have the territorial aspect and the proof. So basically, what our applicants are doing now, well, in my recent context with applicants, they are trying to write the claims in such terms as to allow infringement, yeah? As to allow making them work in infringement cases. Of course, obviously, we are not experts in that field. We are the patent granting authority, but our applicants have in fact clearly voiced also this concern. It's a matter of how do I prove that somebody is indeed infringing my monopoly? Well, the only answer that we can give is a very good claim drafting is important, where you try to clearly define what is the main characteristic of your monopoly, with a view on infringement, with a view on how will I prove that somebody is in fact doing exactly these steps. So I think this is the whole art which our counterparts, the patent attorneys, are mastering so well, in fact.
But I think that the gentleman also referred to an additional issue, and that was the technical specificities or the technical details involved in implementing the system, which eventually the system engineer that would go and implement the system might encounter. So because when the system engineer is told to program this system, then he or she is told the basic business aspects. Of course, the patent application cannot rely on the business aspects to pass the second hurdle that Koen mentioned. But then, during the implementation, it cannot be excluded that a technical problem has to be overcome. And there, it may be that we enter the area of patentability on overcoming the technical problems.
Yeah. And also, I think if this is implemented also in a device and people can buy the device, of course, then it can be seen. So, of course, some functionalities are implemented somewhere in the cloud, maybe more challenging to do so. I think it is a very relevant question. We are not in the best place to answer this question. We are the patent granting authority, but it's clearly one key answer to that is to go to a very good and advanced claim drafting with an eye on the later infringement.
Just our toy showed the keywords that occurred most among your contributions on the side box are Internet of Things, service, very big, software, SaaS, patents, customer, big data. Does any one of those keywords inspire you another comment? Those are things that concern the audience. Okay, your final question?
Can a court, if there is some sort of patent infringement and the case gets to court, can the court request source of the code of a program in this case?
Well, it's of course depending on the jurisdiction, because if a patent is in a certain jurisdiction. So now today the patents are still valid in individual countries. So we have the unitary patent coming soon, which will create one single jurisdiction in Europe with also an associated court. This is all new. So at the moment, I believe that, of course, a judge can take evidence in any form, and he can then, of course, ask the parties to substantiate their allegations, and probably
Yeah.
maybe Yannis, you know
It
more
will,
about this.
it will still be a national judge. There is not at present a European patent judge, but we are in the process of creating a European, so-called unified patent court, which is a European patent court, and then we will start having a uniform case law, uniform jurisdiction for European patents, and a uniform case law as well. At present, it is still the national judges that deal with European patents once they have been
Yeah, and of
granted.
course, in many of these proceedings, there are inter partes, so we have one party challenging another. So it is, of course, up to the parties to bring the necessary evidence of this infringement, where then the judge will then take evidence and judge on the case as such. But maybe it's really interesting to, as you requested, comment on the main keywords. Well, in fact, this is already what I tried to express. We have this big trend going on. It's the Industry 4.0, the new so-called Industrial Revolution. It's the Internet of Things, the Internet of Everything. So we have functionality implemented by software in cars, in fridges, so in all what we would say more traditional fields of technology. So we as a patent office are also aware of that. And this is why we are working hard on clarifying our standing practice, because we want, well, all examiners, we have 4,300 examiners, which are organized in all these different fields of technology. About 700 of the examiners are working in the fields of ICT, so they are familiar with the practice on how to handle CII, computer implemented inventions. With the ongoing updates and clarification in our guidelines, we want to provide more guidance to the patent attorneys, but also in-house to all our examiners of all the other fields in which, of course, this is coming, the Internet of Things, the new emergence of computer implemented aspects in all fields will be handled in a uniform way according to our standing practice. Would we have time also for our second example? That maybe
We have another 5 minutes.
Okay, very good.
Would you like to answer this question? He
Yes,
has a
please.
question.
I would like to ask if somebody wants to apply for a patent, is he or she going to his own country first and then come to you, or come to you directly?
Okay, so very good question. The very big success of the European Patent Office is in fact that we offer one single procedure to get protection in all the member states of Europe. Okay, so now an applicant, a resident of one of the European national countries, still has the option to first file in his country, but most of the people would file directly with the EPO because it has, of course, the economics of scale, one application, one examination, which then will be resulting in a valid patent in, of course, all these countries.
If you like, you're back on the screen and you want to show us another example?
Yeah, so I think this is another nice example. Maybe Yannis, you can introduce it?
This is a case where you work on your mobile phone and you would like to call the contacts list on your smartphone. And normally, when you activate this function, the contacts list is being presented in alphabetic order. That is a default case. But you might think that a very intelligent inventor has invented a new system, and the contacts list is being presented in another ranking, not in alphabetic order, but in order of previous calls history. So the persons that you have most frequently called in the past, they are presented first. And the logic behind it is that you probably also this time would like to call a person that you have recently called. So this is another way of presenting the contacts list on your mobile phone. And
so I think this is a really interesting one, because if you would now suppose that this is not existing yet, so if you would imagine nobody thought about this, we have no evidence that this already exists.
Thank you.
What do you think then? Would this be something which merits the monopoly protection of a patent. I think that's a more typical example of a CII. So it's implemented in your smartphone. And so what would be your feeling?
Quick survey, you say, yes, it's a nice creation, but it's not a patent. It's a nice application, but it's not technical. Or you say, yes, it's a patent, because there must be some technical trick behind it that's so new and so different. It's not just a nice creation, it must be technically new and invention. Do you think that? Two of you think so.
It would be interesting to hear the view of the gentlemen who think it's worth a patent.
We have another 2 minutes.
I understand basically that this doesn't exist yet. Okay, we're not talking about now. It doesn't exist. So it's a novelty because it hasn't been created before. It's innovative because it's, and definitely CII. It's a computer implemented implementation. So I think it deserves a patent. If it didn't exist until now, of course.
Maybe we don't focus on the final question, do we get a patent or not? Maybe we focus on the crucial question that the examiner would pose to you if you would be the applicant. What is the technical problem overcome by this method? What is the technical problem that has to be solved in order to come to this, let's say, invention? And then just let me indicate that the applicant would have to substantiate, to explain what is the technical problem that has been overcome in order for this application to merit a patent.
Thank you very much, Koen Lievens and Yannis
Skulikaris.
I'm learning, I'm still learning. It's been very impressive. The examples were very clear. We've learned a lot in that hour, even those who are not programmers and who are not inventing programs every day. Thank you very much.
Thank you.